Womp bom balloon bom 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 to the boot, oh root, 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 to the boot, oh root. Oh womp bom balloon bom 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 bom. I got a girl named Sue. She knows just what to do.
Okay, section 5.4 is on graphing basic trigonometric functions. This is going to be a long video. If I can get this under 30 minutes, it's a minor miracle. Okay, so we're going to start today by graphing the sine function and the cosine function, and then a couple days from now we'll do the tan function. So what we're going to do is we're going to graph the mother function of the cosine function. Well, let's do the sine function. Y equals sine x we're going to graph. And in order to do that, we're going to use our unit circle. And what we're going to focus on is these points here. These are the most important points when doing our cosine and sine functions. So what degree was this right here? A standard position angle right there is 0 degrees or 0 radians. Here it is 90 degrees or pi over 2. It's probably going to be impossible to read. This is 180 degrees. 180 degrees. Wow, that's awful. Or just pi. This is 270 degrees or 3 pi over 2 radians. And then you get back here, you're back to 360 degrees or 2 pi. And then remember, and if you have a unit circle like we have here, in order to get the sine and cosine values, for every point on this unit circle, the coordinates are equal to cosine of theta, comma sine of theta. So what are the points here? This point's 1, 0. This point is 0, 1. This point is negative 1, 0. And this point here is 0, negative 1. So if we're doing the sine function first, the values we're interested in are the second values, this 0, 1, this 0, and this negative 1. Okay, so let's start putting some numbers on here. Our x is the angle, and the angle starts off at 0, and then it goes up 90, 180, 270, but we're going to actually use the radians. You almost always use the radians when you do this. So our next point is going to be pi over 2. Believe it or not, we're not going to go 1, 2, 3, 4. We're going to go pi over 2. Let's put that over, I don't know, 3 spots. So right here, I just arbitrarily picked 3 just to spread it out a little bit. Pi over 2, another 3 spots, we get to pi, 1, 2, 3. Another 3 spots, 1, 2, 3, we're at 3 pi over 2. And another 3 spots, 1, 2, 3, you'd be at 2 pi. You could also have done this with degrees, right? You could have put 9 degrees, 180, 270, 360, but usually we use radians. Okay, and so those are the angles you're going to put into x here. And when you do that, you get these values right here. You can see the highest value you get is 1. Let's put it, I don't know, we'll put it here, 3 spots up. I have no idea why I'm putting it there. And now I'll put the negative 1 3 spots down. I'm just spreading it out. Yes, you could put 1 right there, negative 1 there, but this will just spread it out a little bit. Okay, and now we can do our points. When we have sine 0 is equal to 0. So it goes right there. Sine, maybe I should use a different color. Let's use green. Sine 0 is 0. Sine pi over 2 is 1. Sine pi is 0. Sine 3 pi over 2 is negative 1. And sine 2 pi is 0. Okay, there's your graph. Now, how does that look? Does it go like jagged, straight up, straight down? No, it doesn't. How do I know that? Well, if I was to take another point here, like this point, that's halfway between 0 and 90 degrees. That's 45 degrees or pi over 4. I don't know if you remember, but that point is root 2 over 2, root 2 over 2. Look at the unit circle if we don't remember. Root 2 over 2, I mean, I have no idea what that is. But if you take your calculator and figure that out as a decimal, you end up with root 2 over 2 being 0.71. So another one of our points would be pi over 4, which is halfway between 0 and pi over 2. Halfway between 0 and pi over 2 is awkwardly right here. And we would go up to 0.71. Oh, again, this is awkward. 1/3, 2/3, so this is 0.66. 0.7 would probably be something like that. And then it would be the same when you come down right here, also halfway between the pi over 2 and the pi over 2 and pi, halfway between, it would be at that same height at around there. So you don't have to worry about this too much. I'm just showing you this just to convince you, hopefully, that it's not a straight line between here. What it forms is a smooth curve, which I'll do my best to draw. Very difficult on this. It's not bad, like that. Perfect. Now, here's the cool thing about these graphs. These are periodic functions, and what that means is they repeat over a specific interval or period. This is the period right here. Do you see that this graph would now start to repeat? It would now start going up again, just like it did here. It went up, down, up to this x-axis, and then it starts increasing again here. Why does it do that? Because if you think of the unit circle, we've gone from 0 to 90, 90 to 180, 180 to 270, 270 to 360. What could we do next? We could keep going. So my point is you could keep going around and around and around the unit circle, and this graph would keep going up and down and up and down and up and down. So just to show you that, our next point out here, if I go 3 more points out, 1, 2, 3, 3 more, would be, this is pi over 2, 2 pi over 2, or pi, 3 pi over 2, 4 pi over 2, or 2 pi, so this is 5 pi over 2. 5 pi over 2 is the same as going all the way around 360, or 2 pi, and then going 90 more degrees, or pi over 2 more degrees. So it's coterminal to 90 degrees, or pi over 2. What's the sine value at pi over 2? 1. So this value as well should be at 1. I'm going to draw this dotted because this is, although it continues like this forever and ever and ever and ever and ever, the period is just this solid line here, right? That's the part where you see the entire curve in there. You can also do it on this side. If this is pi over 2, what would it be down here? This would be negative pi over 2. What would that mean? Well, that would be like on your unit circle, going in the negative direction, this amount. What's that coterminal to? That's coterminal to 270 degrees. What's the sine value at 270? Negative 1. So this value here would be at negative 1. Dotted. Don't have to dot it, but just to give you an idea. This goes on and on forever. This goes on and on forever. Okay? There you go. That's the mother function of a sine function. What's the domain? We're going to write down all this important stuff now. What's the domain of this? Well, we said it goes on and on and on forever, so x is an element of all real numbers. What's the range? The lowest value is negative 1, the minimum value. The highest value is 1, so negative 1 is less than y, which is less than or equal to 1. The period. Well, the period is from here, 0, up to here. That's when it starts repeating. So what's that distance? The distance is 2 pi, or 360 degrees. And that should make sense. The graph doesn't start repeating until you make it all the way around the unit circle. And how far is it around the unit circle? 2 pi, or 360 degrees. The amplitude. The what? The amplitude. You might have heard of this word before. Basically what the amplitude is the distance of a maximum or minimum point from the center line. So the distance from the maximum or minimum point to the center line. Well, in this case the center line is right at the x-axis, isn't it? It won't always be. In this case it is. So if you take the different distance from the maximum point to the center line, how far is that? It's 1. The amplitude is 1. You could also have looked at the minimum point and looked how far that is from the center line. It's still 1. You could also get the amplitude by taking the maximum value, subtracting the minimum value, and dividing by 2. So in our case, the maximum value is 1. The minimum value is negative 1, so 1 take away negative 1, and then divide by 2. That's the same as 2 divided by 2, or 1, and that's exactly what we got. Okay, the y-intercept. The y-intercept is 0. Y-intercept is 0. And the x-intercepts, there's a whole bunch of them. X-intercepts at 0, pi, 2 pi, guess where the next one will be? 3 pi, and it goes on and on and on. But that's not all. We could also go in this direction. Guess where the next one will be down here? At negative pi. So plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and it goes on and on and on. If you want to do that in degrees, it's 0, plus or minus 180, plus or minus 360, plus or minus 540, and it goes on and on and on. Okay, cosine graph. Let's get the mother function for cosine graph. Cosine function. Well, it turns out, because we're using the same unit circle, we're going to use all the same points, these pi's over 2, the pi's, even the 1 and the negative 1, because if you look, This time we're looking at the cosine values. The cosine values are the first values here. So we're looking at this 1, this 0, this -1, and this 0 here. So again, the highest and lowest points are 1 and -1. So we're going to set it up exactly the same. Let's do that right now before we do anything else. So I have 0 go over 3 spots, 1, 2, 3, and I have pi over 2. 1, 2, 3 pi, 1, 2, 3, 3 pi over 2, 1, 2, 3, 2 pi, 1, 2, 3, 5 pi over 2, 1, 2, 3, negative pi over 2, up 3, you get 1, down 3, 1, 2, 3, you get -1. Okay, we're ready. So, at 0 degrees or 0 radians, what's the cosine value? The cosine value is 1 this time, so we're going up to here. At pi over 2 or 90 degrees, what's the cosine value? 0. At pi radians or 180 degrees, the cosine value is -1. Probably getting a sense, it's just fluctuating up and down again. At 3 pi over 2 or 270 degrees, the cosine value is 0. And then once we go all the way around, we're back where we started at 2 pi. It's right there. So this is your the entire period before it starts repeating. It comes down up like that. This should go more like that. Anyway, so that's the period. Now it would continue forever like this, right? And it would continue, this would come down to here, and it would continue. But the period, one incomplete period, you can see it right there. Now, what you might notice is that this graph and this graph look exactly the same, except they're just shifted over to the left, to the right. This is actually true. Cosine graph, sine graph, you can, for one particular graph, you could have an infinite number of equations that describe it. One of them could be a cosine, one of them could be a sine, you could do all sorts of horizontal shifts. So it's a bit strange, but let's just stick with the basics for now, so don't worry about that yet. Okay, what's the domain and the range and all that of this one? Well, the domain, again, it goes in both directions forever, so x is all reals. The range, lowest value is -1, highest value is 1. The period, it starts here and it starts repeating here, it's 2 pi. Again, you'd expect that because that's when the unit circle, you get all the way around the unit circle. Amplitude, well, the center line's at the x-axis. From the highest point to the x-axis is 1. The y-intercept, hey, so far up to here, everything's exactly the same. The y-intercept's the first thing that's different, and the y-intercept is 1. X-intercepts, okay, we have pi over 2, and if you look, you also have negative pi over 2, so plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, plus or minus 7 pi over 2, etc., etc. There you go. Alright, those are your basic mother functions. Now what we're going to do is we're going to take a look at these forms of the equation, which is once you've done all your transformations, just like we've done throughout this course. What does the A do? What does the B do? What does the C do? What does the D do? Good news, they do the same things they've always done. So, amplitude we've talked about a little bit. Let's take a look at what the A value does. The A value, just like before, is a vertical stretch or compression. So for example, say I had the number 3 in here. Y equals 3 cosine x. Do you see that what that would do is, instead of having this value of 1, you'd multiply it by 3. The curve would now go all the way up to 3. So what does it now impact? It's now impacted the amplitude. In fact, it turns out that the amplitude is equal to A. However, it's not just A, it's the absolute value of A. Because sometimes A is negative. What happens when A is negative? You know this. If A is negative, you get a vertical reflection over the x-axis. But whether A is positive or negative, the way you get the amplitude is you just take the A value in the equation and take the absolute value of it. Pretty easy. Okay, what does B do? Well, B is inside the function, and it's a multiplier. It must be a horizontal stretch or compression. And this time, if B is negative, there's a reflection over the y-axis. Okay, if I had, for example, cosine 2x here, Do you remember from before? This would cause a horizontal, would it be an expansion or compression? It'd be a compression, right? It's kind of opposites, remember this? So in other words, this graph here would get squished inwards this way and this way. So what would that change on this? That would change the period, wouldn't it? Yes, indeed it would. So what we have is a little equation here for period that involves b. And basically what the period equals is 2 pi divided by b. But again, it's not just b, it is the absolute value of b. This is very important. Actually, this is really important too. Let's put a box here and write amplitude in there. These two things you're going to use all the time. Okay, next, C. C, just like before, is a horizontal translation. You also call it a phase shift. Only when you're talking about trigonometric functions, you also call it a phase shift. No idea why they couldn't do that all the time, but that's what they do in this case. And D is, just like before, a vertical translation. But when you're talking about trigonometric functions, you give it a different name, vertical displacement. Doesn't matter if you use horizontal translation and vertical translation, or you can call it these two things. Your book will probably call it these two things. One last thing, there is a way to get vertical translation, the d value. You can get the d value by taking the maximum value and subtracting the amplitude. So for example, in our question here, if we took the maximum value, which is 1, and subtracted the amplitude, which is 1, you get 0. So that means our d is 0. And that's true. There is no vertical displacement in this case. It has not been shifted up or down. I don't find this one quite as useful because you can often figure it out even without using this equation. So I'll just box these two. Okay, onwards. Find the amplitude, period, phase shift, and vertical displacement of the following. Here's my A value. Here's my B value, C value, and my D value should be right there. It's missing. The amplitude is equal to the absolute value of A, so the absolute value of -2, which is 2. Done. Let's do the phase shift next. The phase shift, if the C value is -pi/3, the phase shift is pi/3. Vertical displacement, there's no number there, so the vertical displacement is 0. Okay, the period. Remember, period, I'll write it up here again because we're going to use it a couple times. Period equals 2 pi divided by the absolute value of b. So if my b value is 2/3, to get the period, I have to go 2 pi divided by 2/3, which is the same as 2 pi times 3/2. Hey, I can cross out these two 2's. I'm left with an answer of 3 pi. That is my period right there. Okay, next one. Now, before we do anything else, you have to recognize here this is not in the correct form. How come? Because the x needs to have a coefficient of 1. So we have to factor out that 1/4. So we get y equals sine 1/4 x plus, how do we figure out this amount right here? That's confusing. Well, what did we do to the 1/4 to get it out of there? We did 1/4 divided by 1/4. That's exactly what you have to do here. You have to do pi/2 divided by the 1/4 that you took out. So that's the same as pi/2 times 4/1. And then we can do some simplifying. This 4 becomes a 2. So you end up with 2 pi/1 or just 2 pi. You get 2 pi here. Now, if you're not sure, try it. 1/4 times x is 1/4 x. 1/4 times 2 pi is 2 pi/4, or pi/2 in those terms. Yay, I got it right, so we're good. Okay, now you have your A, B, C, and D value. Amplitude is just the absolute value of A, and A is 1. The absolute value of 1 is 1. Let's do phase shift. If it's 2 pi in here, the phase shift is -2 pi. If it's +3 here, the vertical displacement is 3. To get the period, remember period is 2 pi, this black formula here, 2 pi divided by b, which is 1/4. That's the same as 2 pi times 4/1, or 8 pi. There you go. Okay, last type of question. They give us some graphs, and we have to figure out what the equation is. Now, as I said before, there's multiple equations we could use. In fact, this could be a cosine graph, this could be a sine graph, and what this question asks us to do is to do both. Write what a cosine graph would be of this, and also write what a sine graph would be of this. Even in that case, there's multiple graphs, because maybe this thing shifted a little bit to the right, or maybe it shifted way over to the right, or maybe it shifted to the left, or way over to the left. So they give us some rules to follow here. A has to be positive, B has to be positive, and C has to be non-negative. So C has to be positive, or it can be 0. All right, let's see what we can figure out here. We have to figure out A, B, C, and D, right? And it actually turns out that the A, the B, and the D are going to be the same whether it's a sine graph or a cosine graph. It's just the C that changes. So here, the way I like to do it is I start by figuring out where's the center line, the line that's right in the middle. And since it goes up to a maximum of 1 and it goes down to a minimum of 1, a negative 1, the center line's right in the middle of 1 and negative 1, which is right at 0, right? So the center line is right here. And I don't think I'm going to draw the whole thing, but it comes all the way out here, right? So if the center line's at 0, what does that tell us right away here? It tells us there's no vertical displacement, because that's what it's like in the mother function. So D is 0. Well, that was nice. Okay, once you have, well, what the heck, I'll keep drawing this. Once you have this center line, you can also find the amplitude. The amplitude is the distance from the highest point, 1, to the center line. So that's a distance of 1. Or it's the distance from the lowest point, negative 1, to the center line. And that's also 1, that distance. Or the other way you could do it is you could take the maximum value, which is 1, take away the minimum value, negative 1, and then divide by 2. So that's 2 over 2, the amplitude is 1. So we have an A value of 1, a D value of 0. Next, let's get the B value. Well, remember the B is associated with period. So we got to look at the period of this thing. Now, unfortunately, I just realized this graph is not the greatest because it's a tiny bit off. So just work with me here. There's 5 points you want to really nail here. You want to take a look. Where does this graph cross that center line? Oh, it crosses it right there at negative 1. And I know it's not the greatest, but it's supposed to cross right there at 2. Make a big dot there. I'm sorry. Okay, so you want to get those 2 points. You want to see where does it hit its maximum point. That should be 2 over here, 1, 2, right there. Again, a little off. And you want to get where does it get its minimum point. That should be 2 over from negative 3. That one's not too bad. And 2 over from 3. Okay, normally those dots would be much easier to find. Like those would be perfectly pretty points right there. And you'd want to get those 5 points right there. All right. Which 2 points would help you define the period? Well, it's not from here to here. That's not an entire period. It's not from here to here. It's from here all the way over to here. This is the length of the period. So how far is that? Well, this is negative 2.5 down here. And this is at 3.5 over here. So what's that distance right there? If you remember, if you don't, you can probably just look at it and tell. If you don't know how to do that, you can subtract the 2 numbers and take the absolute value of them. So you get the absolute value of negative 6. Whoops, I don't know why that's there. The absolute value of negative 6, which is 6. So the period is 6. That doesn't mean the B value is 6. It means the period is 6. Remember that the period is equal to 2 pi over B, and we've just found that the period is 6. So how do we get what that B value is? Well, why don't we put this over 1 and cross multiply? So we get 1 times 2 pi divided by 6. B equals 1 times 2 pi is 2 pi divided by 6, which is pi over 3. So now I have my B value. It's pi over 3. All right, we can almost write the whole thing now. Let's actually write a whole bunch of this. What we have is y equals A, but A is just 1, sine B, which is pi over 3, x minus, we know it's minus because C has to be positive, has to be a non-negative number, so this value right here has to be positive, and D is 0, so just like that. And we also can do the same for cosine. Y equals cosine pi over 3, x minus, and there. So we got to figure out what's the C value. All right, well, in the sine case, if you look back at the sine mother function, do you see how the sine mother function starts with, it goes right through the origin and it goes up. So at that center line, it's moving up away from the center line. Where does that happen right here, that the graph is moving up away from the center line? Well, it happens right here. So that's at -1. But the problem with that, that means it's shifted over 1 to the left. That would be +1 here. But it says that our, I mean, that's not wrong. Like if you put +1 there, it's totally true. It totally matches this graph. But they've told us that the C value has to be positive or 0, so it doesn't work. So what we need to know is, when is this graph going to come back up and hit here? Well, if it hit at -1, and then it hits again at 2, which is 3 later, when's it going to hit again? It's going to hit again at 5. This is a little off. It's going to come up here at 5. So that means that this whole graph has been shifted over 5, because that's when you would have this leaving the center line, moving upwards for the sine graph. So you could have had +1 here, and it would be correct, except it says C has to be a positive number, so it's -5. Remember, your C value here is 5, not -5, it's 5. Okay, for cosine, if we look back at our mother function for cosine, you can see that cosine starts at a maximum value and moving downward. Where do you see a maximum value and then moving downward? Oh, I see it right here, a maximum value and then it's moving downward. So how much is this? Because if this was shifted back over there, it'd be perfect. So you must have shifted it half a unit over to the right. So this is -1/2. That's how much it's been shifted. So again, we want to get our A, B, C, D values. I'll just do A, B, D, because those ones are the same for the sine and the cosine, and then we got to figure out C after. Okay, first thing we do is we find our center line. The center line is not at the x-intercept this time. You can see the highest value is 4 and the lowest value is -2, and right between 4 and -2 is 1. This is the center value this time. So what does that tell you? It tells you that there's a vertical displacement of 1. The next thing we can get is the amplitude. That's the distance from the highest point, the maximum point, to the center point. Well, that's 3. We could also take our maximum point, 4, subtract the minimum point, which is -2, and divide by 2. And if you do that, you get 6/2, which is 3. Yep, we got that. Okay, B, we need to get the period. So let's take a look of where this thing starts to repeat. There's a bunch of places you could look here. You could look from this low point to this low point here, or this high point here to this high point here. Let's find the 5 points we're really interested in. So I want to find the points where it's exactly touching the center point. So that's there and there. I want to see that highest point, so that's up here. I want to see the lowest point, and then it's coming back up right there. So this would be one period from here to there. So what's the distance? How far is it from there to there? Well, I don't know. There's no numbers down here. This annoying question has no numbers. The only thing that tells you is that this value right here on this line, that's pi. So how much is each one of these? Well, how many spaces did it get to pi? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, to go one space then is 1/12 as much. It must be pi over 12. This would be 2 pi over 12. This is one we care about because it lines up with that. This would be 3 pi over 12. And 3 pi over 12 is the same as pi over 4. So this is pi over 4. Remember, it was also 3 pi over 12, 4 pi over 12, 5 pi over 12, that's one we care about. 6 pi over 12, 7 pi over 12, we want that one. 8 pi over 12, 9 pi over 12, we care about that one. And 9 pi over 12 is the same as 3 pi over 4. 3 pi over 4. Okay, great. So now to get the period, we're going from pi over 12 up to 3 pi over 4, which remember was the same as 9 pi over 12. So what's the difference from pi over 12, or 1 pi over 12, up to 9 pi over 12? This distance from here to here is the distance from 1 pi over 12 up to 9 pi over 12, which is 8 pi over 12, and 8 pi over 12 is the same as 2 pi over 3. Wow, all these fractions. So 2 pi over 3 is the period. But remember, period is equal to 2 pi over b. So how much is b? Well, if you just look at it for a second, you should be able to figure that out. I'll give you a second to look at that. If 2 pi over 3 equals 2 pi over b, then I hope you agree with me that b equals 3. If that doesn't make sense to you, you could certainly cross multiply. 3 times 2 pi is 6 pi, divided by 2 pi, you end up with 3. So b is 3. Okay, we are now ready to write almost the entire equation. We have y equals a, which is 3, sine b, which is 3, x minus something, and then plus 1. And we'll have the same thing for cosine. Y equals 3 cosine 3 x minus something plus 1. All we have to do is figure out our c values. So to get c, let's do it for sine first. We take a look. Remember, we think back to our mother function. And we're interested in when does the sine function cross the center and move upwards, up and away from the center line. When it moves up and away from the center line is right here. This is the first time it happens. It also happens up here, but we want the smallest one possible. So it moves up and away right there. How much is the shift there? It's been shifted over pi over 12. So we end up with minus pi over 12 here. Okay, for cosine, remember we're looking for when does it have it from its maximum value move down? When does it move down from its maximum value? Where's the first time it's moving down from its maximum value? Oh, I think the first time it's moving down from its maximum value is right here. So how much has been shifted over? It's been shifted over pi over 4. And it turns out that these two graphs, these two equations, describe exactly the same graph, right? If you were to throw this in a graphing calculator and throw the second one in the graphing calculator, they would go exactly right on top of each other. Same with these two we found up here. If you were to put the first one in the graphing calculator and the second one in the graphing calculator, you would find that they're exactly the same equations. How exciting. Take care.
She knows how to love me, yes indeed. Boy, you don't know what she do to me, to the fruit.